Hello students, let us continue the session on triangles. In today's session, we will be discussing about Pythagoras theorem which we had learned in previous classes. But in class 10th, we will be learning Pythagoras theorem in a different approach. We will prove Pythagoras theorem using the basic proportionality theorem or the Thales theorem. Before we get into the actual proof, I want you to observe if in a right-angled triangle, say ABC, right-angled at B, if we draw a perpendicular to the hypotenuse AC, what things we can observe? I have considered the part ADB inside the triangle ABC. I am going to compare these two triangles. In both the triangles, we have got angle A common. It's angle A for ADB as well as angle A for ABC. It's a common angle, and angle ADB is equal to angle ABC 90 degree. So by AA similarity, we have got the triangle ADB similar to the triangle ABC. At the same time, if you consider this part BCD, the triangle BDC will also be similar to triangle ABC. If you compare both these triangles, they are similar. The smaller triangles are similar to the complete triangle. So I can conclude that the triangle ADB is similar to triangle ABC. Triangle BDC is similar to the triangle ABC. So these two smaller triangles which are there inside, they are also similar. This particular thing is stated as a theorem, and the statement is: if a perpendicular is drawn from vertex of right angle of a right-angled triangle to the hypotenuse, then the triangle on both the sides of the perpendicular are similar to the whole triangle and to each other. Why we require this particular theorem? This theorem is required to prove Pythagoras theorem. Remember the statement: if a perpendicular is drawn, BD is the perpendicular drawn from right angle, which is angle B. It divides the triangle into two similar triangles, and these two similar triangles will be similar to the actual triangle. Let's use this particular theorem in proving the Pythagoras theorem. What is the statement of Pythagoras theorem? The statement is: in a right angle triangle, the square on the hypotenuse is equal to sum of the squares of the other two sides. Observe, we have got the triangle ABC right angled at B. We need to prove that the square on the hypotenuse AC square is equal to AB square plus BC square. How do we do that? As we have discussed in the previous theorem, the smaller triangle ADB is similar to the triangle ABC. It is done in the previous theorem. If these two triangles are similar, then the ratio of the sides are proportional. The side AD by AB will be equal to the side AB by AC. The sides are proportional. Observe, I can cross multiply. Upon cross multiplication, we get the square AB square equal to the product AD into AC. Let me name this as equation 1. Now I'll consider the other smaller triangle BDC. This will be similar to the triangle ABC from the previous theorem. In this triangle, the sides are proportional. CD by BC will be equal to BC by AC. This implies the square of BC equal to the product CD into AC. Name this as equation 2. Now let's add equation 1 and 2. if these two equations are added up, we get AB square plus BC square as AD into AC plus CD into AC. There is AC common, so AD added to CD. What is the sum AD plus CD? It is nothing but AC, so we get the result as AC square. So sum of the squares of the two sides will be equal to square of the hypotenuse. This particular theorem was earlier given by an ancient Indian mathematician, Bodhayan. And this particular theorem was called as Bodhayan theorem. The statement of this theorem he stated was little different. The diagonal of a rectangle produces by itself the same area as produced by its both sides. This is the statement of Bodhayan theorem. This way of similarity was used by our ancient Indian mathematician Bodhayan. So this theorem sometimes is called as Bodhayan theorem. You can make it a note. Bodhayan theorem. In your previous classes, you have learned if in a triangle the square of a side equal to sum of the squares of the other two sides, it forms a right angle triangle. We may consider that as a converse of the Pythagoras theorem. The statement of the converse of Pythagoras theorem is, in a triangle, if square of one side is equal to sum of the squares of the other two sides, then the angle opposite to the first side is a right angle. The first side is the hypotenuse, is a right angle. Let me consider the triangle ABC, in which AC square is given equal to the sum of AB square plus BC square. We need to prove that the side opposite to AC, the angle opposite to AC is a right angle. So given is, in triangle ABC, AC square is equal to the sum of BC square plus AB square. We need to prove angle B equal to 90 degree. Here you observe I have considered one more triangle. This is the construction required. We consider one more right angle triangle such that the side AB and side PQ are equal, the side BC and side QR are equal. So the construction is construct triangle PQR such that AB equal to PQ, BC equal to QR. Now from triangle PQR we have I have constructed a triangle such that the angle Q is 90 degree. I'll mention that too. Angle Q is 90 degree such that AB is equal to, okay, alright. Now when angle Q is 90 degree, we can make use of Pythagoras theorem. So the square and the hypotenuse is sum of the squares of the remaining two sides. Now by the construction we have, instead of PQ, AB, instead of QR, BC. This is from construction. But given that AC square is the sum of BC square plus AB square. This implies that PR square is equal to AC square. If square root is taken on both the sides, we get PR is equal to AC. Let's name this as equation 1. Just observe, we need to consider triangle ABC and triangle PQR. Triangle ABC and triangle PQR. In these two triangles, we have AB is equal to PQ, BC is equal to QR. These two are from construction, by construction. And we have AC is equal to PR. It is from 1. In the earlier case, we have proved that AC is equal to PR. Therefore, the triangles are congruent to each other, is congruent to triangle PQR by SSS congruency. This implies that angle B will be equal to angle Q. This is from CPCT. If angle Q is 90 degree, the angle B becomes 90 degree. Hence proved. Remember, most of the time in the examination they may not ask to prove the converse of Pythagoras theorem or Pythagoras theorem. They'll ask a different question which is related to this particular theorem. Let's solve the exercise 6.5, which is related to Pythagoras theorem. Let's take up the first question of the exercise 6.5. Sides of the triangle are given below. Determine which of them are right-angled triangles. In case of right-angled triangle, write the length of the hypotenuse. Remember, in class 7th, we have learned that a right-angled triangle will be having the longest side as the hypotenuse. So once if you prove whether it's a right-angled triangle or not, we can easily identify the hypotenuse. Look at the first one here. In the first one, we have the side 7 centimeter. So if you do the square, 7 centimeter square is 49 centimeter square. 24 square if you do, it will be 576 centimeter square. If you do 25 square, we'll be getting 625 centimeter square. If you add 49 along with 576, we exactly get 625. So we have 49 centimeter square plus 576 centimeter square equal to 625 centimeter square, or we can write this as 7 centimeter whole square plus 24 centimeter whole square will be equal to 25 centimeter whole square. These sides satisfy Pythagoras triplet. Hence, the triangle formed by these sides is a right triangle or right-angled triangle. Therefore, hypotenuse is the longest side. Here in this case, the hypotenuse is 25 centimeter. The rest of the 3 sub-questions you can solve. Let me tell, the combination of 3 square, 8 square and 6 square, you may not get a right angle triangle. because 9 plus 36 you will not get it as 64. It doesn't form a right angle triangle. If you consider the third case, 50 square is 2500, 80 square is 6400, 100 square is 10,000. We will not get 2500 plus 6400 as 10,000. This case is also not a right angled triangle. If you look at the fourth one, 5, 12 and 13, exactly they form a Pythagoras triplet. They satisfy the Pythagoras triplet, hence it forms a right angled triangle. In this case, 13 centimeter will be the hypotenuse. Always remember, first we need to identify whether it's a right angled triangle. Once it's a right angled triangle, the longest side will be the hypotenuse. Second question. PQR is a right angled triangle, right angled at P, and M is a point on QR such that PM is perpendicular to QR. Show that PM square is the product of QM into MR. If I consider a right angled triangle, right angled at P, we get triangle PRQ as a right angled triangle, right angled at P. There's a perpendicular drawn on the hypotenuse from point P. Okay, this will be the figure. Let me consider the angle MPR, this smaller angle as X. This angle will become 90 minus X. So let me mention that. Let angle MPR be X. So the angle MPQ will become 90 minus X. In triangle MPR, angle MPQ will be equal to 90 degree minus angle MPR. So this will be 90 minus X. At the same time, we have got angle MQP, which is 180 minus 90 minus 90 minus X. On simplification, we get it as only X. So I want you to observe these triangles QMP and triangle PMR. Observe these two triangles. Angle MPQ is equal to the angle MRP, and angle PMQ is equal to the angle RMP, and also we have got angle MQP equal to the angle MPR. So by AAA similarity, the triangles are similar. So triangle QMP is similar to the triangle PMR by AAA similarity. Once the triangle are similar, the corresponding sides will be in proportion. QM upon PM will be equal to MP upon MR. On cross multiplication, we get PM square equal to QM into MR. This is MR. Hence, we have proved it. Remember, this is one of the important questions. Question number 3. In figure 6.53, ABD is right angled at A. AC is perpendicular to BD, we need to show the three subparts. Let me consider the first subpart. To prove that AB square is product of BC into BD, I'll consider the triangle ADB and triangle CAB. Observe ADB and CAB. There is angle B common. Angle ABD is equal to the angle CBA, its common angle. And we have got two right angles, angle DAB, which is equal to the angle ACB. Both are right angles. Therefore, triangle ADB is similar to triangle CAB by AA similarity. Once the triangles are similar to each other, the corresponding sides are in proportion, I can write AB by CB equal to BD by AB. Now if you cross multiply, we get the result AB square, which is BD into CB. So we have done the first part. Now to solve the second part, let me write it here. I'll consider the angle CAB to be some x. So in triangle CBA, we have 180 angle CBA as 180 minus 90 degree minus x, which is 90 minus x. Similarly, in triangle CAD, we have angle CAD equal to 90 degree minus angle CAB, which becomes 90 minus x. So angle CDA will be, by angle sum property, 180 minus 90 minus 90 minus x, we get it as x. Now you consider the triangles CBA and triangle CAD. We have angle CBA equal to angle CAD. Both are equal to 90 minus x, and CAB equal to angle CDA. Both are equal to angle x. Therefore, by AA similarity, the triangle CBA is similar to the triangle CAD. If the triangles are similar to each other, by AA similarity, the sides are in proportion. AC by DC will be equal to BC by AC. By cross multiplication, we get AC square as BC into DC. The second part is also done. Let's solve the third part. For solving the third one, I'll consider the triangles DCA and triangle DAB. Observe the triangle DCA and DAB. In these two triangles, we have got angle DCA, which is equal to angle DAB. Both are 90 degree. And angle CDA is equal to angle ADB. Angle B is a common angle. Therefore, the triangle DCA is similar to the triangle DAB by AA similarity. Therefore, DC upon DA will be equal to DA upon DB. DC is same as CD, DB is same as BD, DA is same as AD. If you cross multiply, we get AD square as the product BD into CD. This is what is required in the third one. Hence we have proved all the three. Remember, these type of questions, when you are observing somebody solving, you'll feel that it's very easy, but then you need to try on your own. Then only you will understand much better and you can retain this concept for the long. With this question, I'll end today's session. There are totally 17 questions in this exercise. The remaining questions we shall see in the next session. Thank you.